targeted audience and who should join this course. People working in DevOps or who is cloud administrator or cloud engineers and cloud architect guys. So these people should do this one, and even beginners or freshers also can join this course because we will be diving in deep. Okay, we will not be seeing Docker and Kubernetes just few things and then course will be done. Like how it happens if you are going with any DevOps course, what happens is they will be teaching you, and there will be 4 5 subjects will be there: Docker, Kubernetes, Linux, Git, Jenkins, Maven, blah blah blah, Terraform, AWS, something, right? So that DevOps course can give you the insight what exactly these things are, how these things works all together. But nothing or no any subject will be there in deep dive, right? So basically, here we will be learning Docker and Kubernetes in deep dive. Lots of things will be there. Basics of Linux. You should already have understanding of Linux OS, what exactly it is, and basic of cloud. It is something very important. And YAML, good to know. VirtualBox is nothing but just a lab setup offline on your laptop. If you know these basic things, that's fine. If you don't know, then while working or implementation of a lab, you will be having clarity about this. I hope all of you might be having clues what exactly it is, right? Yeah. Now, guys, see the course objective here. Very first of all, we will be starting with Docker. Okay, what exactly Docker is? Its architecture. How Docker came in existence from traditional deployment, how we used to deploy the application over there. Then virtualization came. What is the difference between all three? Traditional deployment, on-premises server, and virtualization, and containerization, a union file system, what type of volume we have, how container deal with the data if we are not using volumes. You know, containers are ephemeral. As soon as your container is getting deleted, data will be deleted. So how to go with the volumes? What type of volume option we have? That we will be learning here, right? How containers are getting created through Docker images. Exactly, Docker images is, and how we will be creating container out of it. Pre-built images and customized image creation. How to use existing images on the registry. That we'll be learning, and customize images, how we can customize image based on our requirement, how to containerize the application, that we will be diving deep. Okay, this is something very important that you will be dealing in your day-to-day activity once you're joining somewhere as a part of DevOps team, right? And how we can convert running container to image, and then image to again a file, and file to image format, and from image to container. It's a long cycle basically that will be looking into this. And running container with non-root user, how it happens to secure the application. That part we will be looking into. Accessing application outside of the server and access within the server, right? So how we can access means how container to container communication will work. This is what the main thing is, how you can access application internally within the node, and how you will be accessing your application outside of the server. This is something important. Resource, not exactly allocation, but limitation, resource limitation to the container. We will not be allocating any resource to the container, but we can limit, like um, my containers my containers can access how much of the memory or CPU from the host machine. You can limit it. This kind of thing is required while dealing with resource hungry application which require a lot of resource to run. And because of the single container, such container can create trouble for others or even your node wherever the container is running. How to deal with this, we will be diving. And after that, Docker Compose. What exactly Docker Compose is? That gonna here things is started now. So basically, we will be writing everything in a YAML file. Okay, we'll be writing all the code in YAML file, and we'll be executing that YAML file to start multiple container at single go. Okay, so this is how Docker file, or sorry, Docker Compose gonna help us to start multiple containers at the same time when it is required to start multiple container. See, my application is having some microservices with it, right? Or somehow my database, right? You can say we need MySQL as well. So instead of going and writing all the instruction on the command prompt at once and then execute it and then start your containers one by one, that is not a good idea, because if you are missing some of the instruction or arguments, and again you need to delete the container and recreate it by modifying those options, right? So it's better to write everything in a file and then execute it one. This is what Docker Compose is. Docker file will helpful to create Docker images, to containerize the image, containerize your application basically. Docker file is useful. So this was a bit about Docker, guys, and after that we will be starting with Kubernetes. Why we are having Docker Swarm and Kubernetes. Docker Swarm is a native orchestration tool of Docker. It's super easy to deploy your application. If you are aware of Docker, then same or similar command you can execute here by using Docker Swarm. But Docker Swarm is having very less feature and functionality as compared of Kubernetes. That's the reason no any company is preferring to use Docker Swarm. Everyone is using Kubernetes, which comes up with lots of feature and functionality. Let's discuss one of the feature over here. In Docker Swarm, you will not be having feature of auto scaling of your deployment. Once your deployment is running and somehow traffic spikes up, so new containers will not be added automatically. That you'll have to log in the cluster, then you have to manually scale it up, right? So this is the main problem. And after that, Kubernetes is already there. So Kubernetes is having this feature and functionality with it, and you can use auto scaling feature in Kubernetes. And not only auto scaling, there are multiple features. If you want to go for uh, like you know uh, automated continuous deployment using GitOps, then this is also not supported in Docker Swarm. This feature is available in Kubernetes. You can Argo CD, you can use Flex CD, and you know multiple options are available. So we'll be diving in Kubernetes, right? So Kubernetes, let me go with this course content. Just I mentioned here type of volumes. The type of volumes is mentioned in this detailed content. Basically, uh, is what we discussed: backing up the images in container and all. Building custom images by writing Docker file, registry management, hub.docker.com, and hub, a GitHub. Basically, we can store Docker images on hub.docker.com. This is the place where you can store your images freely, but that will be public only. And another thing is that GitHub, where you can place your images private, no one can see except you. And there are many registries is being used in your company and your project, right? Like Harbor is the one, JFrog Artifactory, ECR, right? And ACR, Azure Container Registry, Elastic Container Registry, Google Container. There are many, hundreds of, but it is not possible for me to go for each of the registry type, right? But what can I make it best thing here is some of the generic steps that applies on all those registries. Means once we are implementing this GitHub one, then you will be able to work with all another type of registries, right? That will be very good thing actually. You no need to go for each or every type of registries, right? How to do that will implementation will be there in our session basically. Docker Compose file. See, few examples are mentioned. WordPress will be implementing database. So, we're learning about Kubernetes. 95% practical will be there. Obviously, theory will be there. Without theory, I cannot start any topic, right? So, first, I will be describing you what is what, and then we'll be implementing. You know, uh, what all things we are going to learn. Very first of all, Kubernetes architecture. From the Kubernetes architecture, we'll be starting. What all components are included in your Kubernetes architecture? What is the use of each of the component? What they are doing? Their job. That we will be discussing here, and after that, deployment of Kubernetes cluster. Yes, this is something important. What type of cluster, guys, we are going to create? So basically, we will be creating kubeadm cluster or kind using kind basically. Kubeadm cluster is a type of cluster. You can refer it like on-premises cluster, right? On-premises machine, on-premises node server, right? So on premises, how you will do, where you'll be installing operating system, you will be responsible for operating system management, you'll be responsible for each and every steps, making it secure, and somehow we can say that installation of Docker, kubeadm, kubectl, all the Kubernetes components we will be installing by our own. In this cluster, we'll have three nodes, one master and two worker nodes. Why I selected this one, Kubedium cluster? Why we are not going for different version or variants of Kubernetes, right? Why we are going for this one, Kubedium? So, guys, the reason is that whenever you are going for interview, those people will ask you Kubedium thing. Okay, they will not ask you another variants of Kubernetes like EKS, AKS, GKE, what all these are. This is the product of AWS. Okay, Elastic Kubernetes Service full form is. Another one is, this is Azure one, Azure Kubernetes Service. This is the GCP thing. Okay, Google Cloud, Google Kubernetes Engine, right? What is the difference between them generally? So whenever we are working with any one of this cloud Kubernetes, so the thing is that you will go and just create the cluster by using Terraform or something like, a graphical user dashboard, right? Their console, next cluster will be ready. No more efforts to do by your own, right? And once your cluster is ready, you can start using it. You can define everything from the console, like how many worker nodes I need, what all things are required to make it. And the main thing about cloud Kubernetes is you are not responsible to manage manually your master nodes. You will be responsible for your worker nodes. Even if you are using managed worker nodes, that will be also taken care by cloud provider. You will be having limited access or control on your cluster. But whenever we are talking about kubeadm, you will have 100% control of your cluster by your own. You will be, let's say, somehow some new version came of Kubernetes. So you will have to update it manually. If you want to perform patching on operating system, you will be responsible for that, right? If any bug fixes or like new releases is happening on operating system level or some another application level, that will be done by your own. But here, EKS, let's say EKS, you are using Kubernetes version 1.20 for an example. Every version in Kubernetes, it will be having deadline. If you are not updating, that will be updated automatically. Okay. Worker nodes versions will not be touched by cloud provider. That is your responsibility. Okay, you'll have to do that if it is unmanaged. If it is managed, then again it will be updated automatically. Okay. So what is the difference major when difference comes into the picture in this cloud Kubernetes versus kubeadm thing? So guys, cluster creation and management of the cluster are back implementation. That will be the different because these clusters are getting created from cloud providers dashboard, right? EC2 dashboard, something you can say that EKS dashboard somewhere. You are logging into the Azure, so in AWS they are saying EC2 to the VMs, but in Azure they are saying VM to VM, like it's a VM. Google Cloud again, uh, VM will be called as a virtual machine VM. So this is small differences, different look, UI, method of cluster creation by going different routes. That thing will be different. The rest of the thing will be the same as it is. Like whenever we are creating pods, we are creating secrets, we are creating deployments, right? Whenever we are creating, what else? Config maps. Whenever we are creating any other daemon set or stateful set, right? Stateful set. So these things, whenever you will be creating any Kubernetes object, will be same as it is on any type of Kubernetes, including OpenShift. OpenShift is again growing fastly. It's a product of Red Hat, created on top of Kubernetes. Whenever Kubernetes is releasing a new version, these people are adopting Red Hat people, and they are releasing under OpenShift. So OpenShift gives you additional facility like graphical user interface and few image streaming or something like image build feature, right? So route service, additional things are there. Obviously, that is paid. OpenShift is not free. Whenever you're creating OpenShift cluster, so trust me, once you're running OpenShift cluster for a week, it might ask you to pay 10, 20,000 rupees, more than 20,000 rupees, because X T to X large minimum these nodes are required to run OpenShift cluster. Here you can through kubeadm on your AWS, you can create cluster by using T2 medium nodes, which is very small nodes, right? Other things, guys. Here, let's go back to the slide and talk about what all things we will be diving here. So pod object, how to create a pod. What exactly pod is? Pod is an object where you will be creating container inside it. Container cannot be created directly in Kubernetes. So a wrapper, we can say that, which will be containing your containers. One pod can have multiple containers. You can communicate very easily by using pod name. Pod name will be treated as host name for multiple containers to communicate with it internally. We will be learning about pod to pod communication. We will be we will be deploying simple application using Nginx or some another application. All right, that we'll be learning about single container application, multi-container application. What is the static pod, init container, how to allocate. Again, allocation is something like limitation, basically, how we can define that our container can access what amount of memory or CPU from the host machine. That we'll be learning here. Replication controller, what exactly replication controller is. Single pod, by using single pod, we cannot achieve highly availability, right? We should have replicas, right? When it comes to achieve highly availability, so things started like this. Let's see here. This is one of my node. This is one of my node, and this is one of my another node. Come on, this is my another server in cluster, right? This is one another node in my cluster. So guys, what happens is, let's see here the thing. I'm running my application, my containerized application here. This is my containerized application. This is my another containerized application. The same replica I'm talking about, right? How to create this kind of replicas, like, how to create container replica, whether multiple on same node or it will be spreading automatically to different nodes. So if one container is getting die, somehow if something is happening wrong to this container, right? So this container should be able to serve the traffic. If somehow something is happening wrong to this node itself, then automatically another node comes into the picture to serve the request through running container in it. It is not possible that at the same time whole node will go down, right? So one node is going down because of some reason, or lack of resource availability or network issue or some incident happened in that. So that node will not be available at the time or even during maintenance. So another nodes will be serving the traffic. This is how we will be achieving highly availability. But to achieve highly availability, we need to have a mechanism that spreads containers or pods in your nodes, right? So this is the thing your replication controller gonna help you to spread your pods replica within that cluster. But it was initially came when Kubernetes was released, replication controller. It was having few drawbacks. After that, replica set got released. Again, replica set was having few of the drawback. After that, deployment thing came. So deployment is the final one. Deployment is the latest one. So deployment comes up with lots of feature, not only this multi-spreading the replica, but it comes up with scaling up or scale down of feature. Automatic, auto scaling feature is also there called HPA, horizontal power auto scaler, which will be allowing us to achieve highly availability if somehow traffic is getting spikes upon your cluster. So it will be adding few more nodes on your not nodes, pods on your uh, cluster so that your application can run seamlessly. And if somehow traffic is going down below the threshold, so additionally created pods will be removed automatically. You no need to touch, you no need to do anything by logging into the machine. Not only this feature, you can perform rolling updates, rollbacks, you can check the deployment, rollout histories, many more, right? So from replication controller, we will be starting till deployment and HPA, right? Each and every basic things will be covered from RC replication controller to replica set and then replica set to deployment. But things are not as stopped here. We are having daemon side. Daemon side is an object in Kubernetes which will be helpful for us to deploy monitoring and logging tools. What is the requirement of monitoring and logging tool, right? See here, I'm having three nodes in my cluster, right? I'm having three nodes in my cluster. So you can assume that these three nodes are the worker nodes, and I want to deploy application containerized monitoring application. It could be Splunk Forwarder or something, Log Stash or something like that, right? To collect the log or in matrices, right? So my pod should be created in each of the node. You don't need to define any replicas. Daemon set is a smart one. It will be just going and checking how many worker nodes are available in the cluster. Okay, three worker nodes. Place one pod in each of the node, right? So this is the main feature of our daemon set that we'll be learning about it. Stateful set is again wow, it's a next level thing. Stateful set is something that uh, let's say I want to create cluster inside cluster. What is this cluster inside cluster? You cannot create Kubernetes cluster inside Kubernetes cluster. I'm talking about cluster inside cluster where you will be running your environment with Kubernetes. Inside Kubernetes where multiple nodes are in your cluster, and you want to install some MySQL cluster inside Kubernetes. If you want to install HashiCorp Vault cluster inside Kubernetes cluster, different technology cluster, I'm referring it. So stateful set gonna help you to perform such kind of things. No, it is a bit different whenever you will create a deployment. So its pod will be created with unique names. If somehow one pod is getting crashed, so one another pod will be placed there with different name to achieve highly availability. Okay, the problem with deployment is you cannot reach to the specific pod, right? It will not allow you. But here in a stateful set, it is super good thing, which will be allowing you to reach it out to a specific pod. How to reach it out to specific pod, that I will be implementing with you practically. And we are having one of the additional service introduced here in stateful set called headless service, which will allow us to reach to specific pod, how it works, what exactly these things are. Stateful sets pod will have static name, and those name can be used as a host name with its FQDN. That will be diving here. And after that, volume type, we are having variety of volumes with us, like, ephemeral volumes and host. You can store, you can store your containers data on the host machine, or as well as you can access host machine's data inside the container by using host path volume. Empty directory is something temporary directory volume which will be created till pod lifetime. Once pod is deleted, everything will be deleted, nothing will be recoverable. Static provisioning, dynamic provisioning, like, what is storage class, what is persistent PVC, PV, everything will be like, discussed in the session. See, since how long I'm talking, it's been already half an hour, I believe. Still, course content is not ended. We are having lots of things still over here with us. See here, services. What type of services are available in Kubernetes to access your application within the cluster? We'll be using cluster IP service. If you want to access your application outside of the cluster, then we are having load balancer and node port. These two services, not only two, one is also there called ingress controller somewhere. This is the one ingress controller. So ingress controller and load balancer and node port. So node port and load balancer. Node port means like, two things are involved in it. Node's IP and the port number range, which is 30,000 to 32,000 something in between that range. And again, load balancer. So like load balancer will be coming up with IP address or a lengthy name in AWS basically. Generally, if you are using GCP or EKS, so it comes up with IP only. But in case of AWS, a huge name will be given to you. So these things cannot be used by our users because they cannot remember IP addresses and the huge names, right? So what we'll do is we will be implementing ingress controller thing here. Once you are implementing ingress, you can access your application by using domain names like anish.com, Visualpath.in. You know, these domain names can be used through Ingress. We will be implementing this thing practically as well, like installation or configuration of Ingress controller and access your application through virtual domains, which will be nothing but same like your real domain names, right? This is something. And after that, here we are having secrets and config map thing. What exactly secret is, what exactly config map is, place your secrets on a to place your secret on a centralized place and then use it in your different deployment in form of like, volume or environment variable. Whenever I'm saying, volume means it could be certificates, PEM files or something, you know certificate and all. So how to use those things, including config map. Config map is something which will be allowing us to keep our few of the centralized configuration in centralized place like environment variable or few of the configuration file. That will be discussed during the session. Config map can help you to replace your containers default files, right? How to implement that we will be discussing. It's a huge topic basically. And again, scheduling. This is a huge one. That was not as compared to that. The huge topic is here. Scheduling and health checks. Let's talk about scheduling. How my pods will be placed in the node. Let's say this is one of my pod. This one is my pod. Now, what I just want to do is I want to deploy this pod on this node based on the node name or based on the node selector label or whether to go into this specific node. And we can define like, not to go in this node, go somewhere else. Okay, and we can define our node thing called taint toleration, which where our node will be selecting whether this pod will be allowed to get deployed in this node or not, right? So these things will be discussed here. Like, few names I want to say here. Node name, based on the node name, based on the node selector. What exactly pod affinity is, pod anti-affinity is. Pod anti-affinity is something interesting, which is that I want to chase to this red pod. I just go and get this green pod. I'm saying that just go and get deployed with a red pod. Okay, this is pod affinity. I'm saying that don't go and get deployed wherever in whichever node if red pod is running. Don't go. Just go somewhere else, here or here somewhere, right? anti-affinity, pod anti-affinity. This is the thing. Uh, Node affinity, node anti-affinity, pod affinity, pod anti-affinity, and taint and toleration. These are the huge topics will be discussed in during in our session, and during this session will be running slow so that everyone can have idea about that. After that, health checks, we are having what type of health checks are available for the container, like liveness and readiness container, liveness and readiness probes, how they are helping us to achieve high availability to make sure that container is running and responding, to check the container health. If container health is not good, then this liveness probe will be restarting your container. Readiness probe, what it will do is once container is not running successfully, it will not be allowing to land any traffic or request on your container, right? Stop basically. How to implement all together, implementing that. After that, guys, here we are having RPAC, something role-based control access, authorization or authentication part. We are working in a team, DevOps team. I'm the administrator there. Let's say a few of you are auditors, few of you are owner of some of the application where you are deploying or you are managing, its history, you're documenting the things and everything based on your job role. If it is required to assign you some of the privileges on the cluster, how it happens, that we will be implementing with RBAC, where we will be talking about user account, service accounts, and kubeconfig file. What exactly kubeconfig file is, how role binding is different with cluster role binding right now, and we will be creating service account and users to implement these things permanently, practically. Sorry, practically. And role binding gonna help you to access a particular namespace permissions. If you want to get cluster-wide access, then cluster role binding will be helpful for you. How to implement in each and everything, that is there. I simplified it. I seen so many, when I was learning Kubernetes, I seen so many trainers are there. They are just keep writing the things and they're creating confusion. So I simplified this difficult topic in very simple and easy way. There you can just catch up the things super easily. No need to bother about this. Wow, this is it, guys, about Kubernetes. Few more things add-ons. Okay, if you would like, you can join these things once it is started. Helm chart, Helm chart is something important these days. Companies are using Helm charts to deploy the application. Whatever things that I discussed, RBAC or this pod affinity, Helm checks, ingress, deployment secret, these all things you will be writing through YAML file. How many YAML file you will have in one deployment, it totally depends. Sometimes you might have 10, 20. It totally depends, right? So Helm chart will allow you to place all the YAML file in a package, and you can modify those YAML files. And during execution of the command, during runtime, you can change the values from the centralized place called values.yaml file. And basically, how you can create your own chart, how to perform deployment using Helm chart and modify the Helm chart, and performing the rolling update and rollbacks through Helm chart, how we were doing it through QCT, or the same thing we can do with the Helm command, right? Helm chart will be covered almost all the things, right? And Argo CD, log stash, see, these three things. Helm chart will be in detail, but Argo CD will be covered almost all things. How, introduction part, basically Argo CD, how to deploy your application or the CD part to Argo CD, how it is picking up your deployment YAML file from the GitHub, right? That will be there. Elasticsearch log stash and Kibana, how to install ELK stack within Kubernetes cluster and see the dashboard, what type of dashboards we are having. Kibana basically here, right? Kibana, how to access the log, see the log in Kibana. After that, installation of Prometheus Grafana within the cluster and see different type of dashboards available for Grafana, how we can import them, how we can make it work. So introductory part will be there for this last three, Argo and ELK and Prometheus Grafana.